version, which essentially says particles are particles and they hop from place to place with a particular probability. And the probability that a particle...
So everyone knows that sustainability and science are closely related. You don't really need a PhD in science to live a more sustainable life. Sure, but it is important to know certain aspects of it. Please do not be scared of this word. I know thermodynamics sound like a scary physics gibberish. And yes, I won't lie, it is complex. But once you get a hand of it, you will realize it's not as difficult as it seems.
Okay, simply put, thermodynamics studies the relationship between heat, energy, temperature, and work. It describes how the energy of a system changes and if it's capable of doing useful work on its surroundings. Heat is transferred in three ways: conduction, convection, and radiation, but it's not as straightforward. So you see, take for example the world of architecture and building design. It's easier to think of heat transfer in four ways: transmission, ventilation, infiltration, solar gains, and internal gains. And of course, these four ways have a specific equation on how to solve them.
And while it's not secret that math is used to calculate the heat transfer, it's not really taught in a lot of schools, specifically architecture schools.
I have studied sustainability and energy in buildings in multiple programs. Some focus on architects and some others to engineers. And the main difference in their approach is that math is almost giving up in architecture. Assemblies, condensation, type of insulation, basic concepts as use value, those are taught and very well taught in architecture, but sometimes it feels that it's missing the very basic of it, the start of it all. How and why energy transfer in the first place, and there is no better way of explaining it than with math. Of course, not every professional is like that. Certain programs like passivehouse requires that the person who wants to get certified have some degree of thermodynamic understanding. It is even part of their study program and exam. And guess what? It's not as complicated as it seems. Sure, it does seem intimidating in the first place, as any piece of algebra does when there are more letters and numbers, but once you get deep into it, you realize how straightforward it is. Luckily, the passivehouse tool does these calculations, so you save some time and mental peace. But this relationship doesn't stop at construction. Mathematics helps us predict impossible scenarios, calculate carbon footprint, explain the relationship between cause and effect, and many things more.
In other words, a sustainable goal that is not backed up with empirical mathematical proof is not a goal at all. It's just not feasible. Sustainability cannot live without math, and I do think it's important for us to learn some basic of it before attempting to set any political goal or sustainability goal.
As I said before, math is not an end goal, it's a tool. But damn, is a useful tool. One that can breathe life into an idea. Is the backbone of any innovation as well as of our own destruction.
I talk about from the view of buildings because that's the industry I work in, and I probably won't do a good job explaining the relationship between math and sustainability in other fields. So if you are someone that is working in the construction industry, whether you are an architect or an engineer, I beg of you, do not lose track of what sustainability is. And if you really want to succeed in it, you probably will want to look at it in the math behind it. The construction industry does hurt the environment a lot in the end. And it's 100 times easier to understand how we can diminish our impact if you actually start thinking with numbers.